Last year, I watched a team spend a small fortune teaching an invoice to file itself. The job was boring and predictable. Read an invoice, pull a few fields, check them against a purchase order, send it on. But autonomous agent was the phrase everyone wanted on the roadmap, so that's what they built. They handed a model a pile of tools and let it work out each invoice on its own. It worked in the demo, and the demos where the trouble always starts. In production, the same invoice took one path on Monday and a different one on Tuesday, and the bill climbed into real money. So here is the question this whole episode is really about. How does a job tell you it wants an agent, a workflow, or something simpler before you write any code? They brought in someone senior to tune it, and she surprised the whole room. She deleted the agent. She replaced it with a plain sequence of steps, one model call to read the fields, and the problem went away. The most senior move in the room was removing code, not tuning it. There is a decision that comes before every other decision in this domain, the choice of pattern. Get it wrong, and you've made one of the most expensive mistakes in the whole job. By the end, you'll have a ladder of 3 patterns and one rule for choosing between them, and a way to break a messy problem into steps you can build. Start at the bottom because the simplest thing here is a real pattern, not a failure to try hard enough. The smallest building block is a single model given a few extras, something to look things up, a tool or two, a little memory. That's the augmented model, the atom everything else is built from, and for a huge number of jobs, it's the whole architecture. One rung up is the workflow, where the model and its tools run along paths you laid down in advance in code. You decide the steps, the model fills in the hard parts, and the route through the system is fixed and knowable. Think of a checklist that happens to have a brain at a couple of the boxes. At the top is the agent, where the model directs its own process, choosing its own steps and tools as it goes. Nobody drew the path in advance. The model draws it at runtime, and it can draw it differently every time. That's exactly what built the invoice team. So, there's your ladder, augmented model at the bottom, workflow in the middle, agent at the top. As you climb, the system gets more flexible and also less predictable and more expensive to run. That trade, flexibility bought with predictability, is the kind of call the exam asks you to defend. Now the rule that sits above the whole ladder, and if you keep one sentence from this episode, keep this one. Anthropic's own guidance is to find the simplest solution possible and only add complexity when it earns its place. Sometimes that means not building an agent at all. So here's the rule: use the simplest pattern that meets the requirement and not one rung higher. Agentic systems trade latency and cost for better performance, and you only want that trade when the task is genuinely hard and open-ended. Flexibility is never free. You pay for it in predictability, and most jobs quietly don't need to be that free. That one rule would have saved the invoice team. Their task was fixed, the same fields and the same check every time, so it wanted the predictability of a workflow. They never had a tuning problem. They had a pattern problem, and you can't tune your way out of the wrong pattern. Architects climb too high in a couple of predictable ways, and the exam loves both. The first is over-orchestration, standing up a whole team of agents when one straight path would do. The second is gold-plating, bolting on every tool and safeguard a system could want instead of the few this job needs. Both feel like sophistication right up until they show up on the bill. The winning answer is almost always the simplest pattern that still satisfies every constraint in the stem. Alright, you've picked a rung. Now you shape the system, and that's where decomposition comes in. Decomposition means breaking one big vague task into smaller steps that each do one thing you can check. The invoice job decomposes cleanly. Read the document, pull the fields, validate against the purchase order, hand it off. Each step is something you can test and fix on its own, and small steps beat one big hopeful prompt almost every time. When an architecture gives you inconsistent output, the exam usually wants decomposition, not a bigger model. Zoom all the way out, and every one of these systems has the same 4-part shape. Something comes in, that's the input, and something happens to it, that's the processing. Something comes out, that's the output. Then the part everyone forgets, a feedback loop that watches what happened and feeds it back to make the next run better. Input, processing, output, feedback, and a system that skips the last one can never improve itself. The exam will show you an architecture with the feedback loop quietly missing and ask what's wrong. So that's the toolkit. A 3-rung ladder, 1 rule, decomposition, and the 4-part shape. Now let's put it to work on the kind of question you'll actually face. Here is the first one, and read it the way you should read every STEM, hunting for the constraint. A logistics company needs to pull the same handful of fields from tens of thousands of carrier documents a day. There is a hard cost ceiling per document, and every extraction has to be reproducible later for an audit. A team proposes an autonomous agent that decides its own steps for each document. Option A is that autonomous agent because it adapts to any layout. Option B is a multi-agent system with a separate agent for every field. Option C is a fixed workflow whose single model step reads the fields into a schema wrapped in validation and retry code. Option D is a single call to the largest model available with a very long prompt. The constraints hiding in the middle, the way it always does, reproducible for an audit. That means the same input has to follow the same path every time. An agent picks its own steps, so it can't promise that an option A is out. That's the wrong rung, an agent's flexibility for a job that never asked for it. Option B, a separate agent per field, is over-orchestration, a pile of moving parts for a job that has none. Option D reaches for the biggest model, answering a design question with a size knob, and it fixes neither the cost nor the audit. Option C is the fixed workflow, a bounded model step in deterministic code, so it runs the same every time, cheap and auditable. The answer is C, the simplest pattern that meets every constraint without climbing a rung too high. Next question, and this one's about shape, not which rung. A team feeds one prompt a long request for proposal. In that single call, they ask the model to extract the requirements, build a compliance matrix, and draft a proposal section. The outputs all over the place, great on one run and wrong on the next. Option, decomposes it into a chain workflow. Requirements, then matrix, then section, each a checkable step passed forward in code. Option B, keeps the single prompt but adds things step by step and a higher token limit. Option C hands the whole thing to an autonomous agent that loops until the draft looks finished. Option D sends the same overloaded prompt to the largest model available. The tell is that one prompt is doing several jobs at once, so the fix has to change the shape. Option B just turns knobs without touching a design that's overloaded at its core. Option C climbs to the top rung for a task whose steps are already known, the wrong rung again. Option D swaps in a bigger model, a size knob standing in for a design decision. Option A decomposes, and because each step now does one thing, you can test it, trust it, and fix it on its own. That's what an inconsistent multi-part task needs. So the answer's A. So the first decision an architect makes isn't which model or which tool, it's which pattern. 3 rungs, augmented model, workflow, agent, and 1 rule. The simplest pattern that meets the requirement, never a rung higher. Break the task into checkable steps and run the flow all the way around: input, processing, output, feedback. That's how you answer the question we opened with. Find the constraint and climb only as high as it forces you to. But real systems are rarely one pattern doing one job. Sometimes you do need more than one agent, and then the question is how many, who's in charge, and whether it's worth the coordination cost